So my name's
well.
Nigel Bayliss. I'm the Optimizer PM. As I mentioned, I try and keep this fairly short. Interrupt if you want, and Chris, if you can just let me know if the questions come in. And the idea is that I go through fairly quickly and then, ask away really. Draw your attention to the usual legal bit. I'm sure you've all seen that before. So what I'm going to talk about SQL Profiles, very, very briefly, SQL Plan Management, give you a quick demo, and then I'll show you how they can be used together, in fact. And then we'll have a quick summary at the end where I do compare and contrast. Just so that you may see some bias. So I have to declare an interest here in that I do own SQL Plan Management, but I do not own SQL Tuning or SQL Profiles. So if you probably detect knowledge gap if you ask very in-depth questions about SQL Profiles, because as I say, I look after SQL Plan Management. And I guess if you detect any bias, feel free to use a pinch of salt or what have you. So full disclosure up front. So let's just take a very quick look at SQL Profiles. Now, for you that don't use SQL Profiles in this way, just bear with me. So this is, if you like, the way that SQL Profiles were originally designed to be used, and then we'll move on to the other ways of using them in a minute. So the idea behind a SQL Profile is that you can, for example, run DBMS SQL Tune, create tuning task, the task executes SQL and figures out whether there are better execution plans or what have you, and will adjust the SQL statement. It will create a profile which will adjust the way the SQL statement is parsed to give it a better plan that it identifies. So in this particular example, we've created a SQL profile. It happens to be using an index range scan. And if you create a plan from the SQL statement, you'll see SQL profile, and then the name is used for this statement. So it's fairly clear when they're being used, of course. What is a SQL profile? Well, if they're used in this manner, if you can actually look inside the internals of a SQL profile and see what's going on in there. And the way that it works, it's actually pretty clever. In fact, it adjusts the cardinality values that are calculated by the optimizers. So it makes adjustments, and it uses this opt estimate hint. So essentially what it's doing is massaging the cardinality hints or the cardinality calculations that are made by the optimizer to nudge it towards the plan that's better. That's really what's behind it. It's simple as that, really. Nice little technique. So I guess to summarize SQL Profiles very quickly, the SQL Tuning Advisor is a great way to find better SQL execution plans. But I'm sure you're all aware that if you do use this mechanism, that the estimates are not good forever. If the data profile changes or things change in the database, then the plan that you get from a SQL profile may change over time. And then things like if a database schema changes over time, then there's nothing really kind of built into a SQL profile that takes that into account. It just says, these are the new estimates for the cardinalities, and then you get the plan that you get. So that's how it works. So I suppose the summary of that is that the SQL profile that you create via SQL Tuning Advisor does not fully constrain a plan. So you can have maybe a variety of different plans, in fact. And but the plans that it does choose are not controlled in any way. They're just taken, the optimizer takes the adjustments that the SQL Tuning Advisor has made to the cardinality hints and then creates the plan. What is really nice actually about SQL Profiles is that you can use force matching. So that means that if you have SQL statements that use literals, you can apply a SQL profile against all of those different SQL statements. So that is a lovely feature, actually, a SQL profile. So down the bottom, an example of what I'm talking about, if you select where customer code equals some literal value, and that literal value changes to customer 234, what have you, then the SQL profile will still match the SQL statement. So the SQL profile can be used on a variety of different, well, the same SQL statement, but with different literals. So it's quite a nice, again, nice little technique. So if we now quickly look at SQL Plan Management, this is kind of a big topic. And so when we look at SQL Plan baselines, they're really just a component in a larger framework called SQL Plan Management. But if we look at the sort of the way that it was originally designed, or the original concept, is that what you can do is capture the plans that are currently being used by the workload. We capture them over time, and in fact you can take them from various different sources. I can see CQ rather than SQL, but anyway, from SQL tuning sets, from AWR, cursor cache, stored outlines, and you can import and export them. So in other words, you can grab execution plans for a whole variety of sources. You know, a real simple approach is that while the application is running, you can actually just load them from the cursor cache. So wherever you want, you create a set of baselines. So the idea here is that you capture them while they're good, and then the SQL Plan baselines kind of enforce those plans going down the line. So once you've captured them, the application continues to run, and then it's using a set of approved plans, so to speak. So the original concept of SQL Plan baselines was to have this kind of strategic approach where you essentially capture everything. And then the idea behind that is that over time, your plan shouldn't regress. So everything is kind of held stable. The plans are not going to regress, but it also incorporates the ability to evolve the plans over time, because in fact, plans don't remain static, which we'll come to in a bit, in fact. So what is a SQL Plan baseline? Internally, it's very different, if you like, used in this way, but bear with me a little while. But if we look inside a SQL Plan baseline, what it uses, in fact, is a full outline. So it uses a hint outline to enforce a particular plan. So the whole point of a SQL Plan baseline is to say, what is the plan for this SQL statement? And then it generates, if you like, a set of hints that enforce that plan. So the idea behind a SQL Plan baseline is it does in fact put a straitjacket around a SQL statement that says you are allowed to use this specific plans, or in fact this specific set of plans. So internally it looks like this. Now, SQL Profiles. Now, this is really where the question, I guess, where things become grayer, because as I'm sure you're aware, there are tricks that you can use to actually put hints or outline hints into a SQL profile. And for those that you don't know, there are Moss notes covering how to do this. So there are scripts, for example, called coexer for SQL or something like that, which enables you to grab the outlines from one SQL statement and apply to another one. And also, in fact, within the SQLT diagnostic tool, there's the same script plus another one that does a similar thing with SQL Plan baselines, in fact. But that one seems to be less well known. So I guess over time, this technique became quite well established, where you can see a plan that you want, and then you grab it and then apply it to a SQL statement, a different SQL statement even. In fact, that's possible with SQL Plan baseline as well. But I think because of the script, it was easy to use, support provided, that became kind of fairly well established as a technique. So in other words, you created, if you like, some kind of overlap really within a SQL profile and SQL Plan baseline, because now the SQL profile has outline hints in it. And so, okay, so why now is that different from SQL Plan baseline? Because internally, yeah, that's got a bunch of outline hints as well. So quick sales job, if you like, here. There are a couple of links that in this deck that you can follow, where I've got scripts that show you how to take one plan from one statement and apply to another with a SQL Plan baseline. So there is plenty of overlap there, in fact. But why would you use one over the other? I think that's the key thing. Where's the differences? What are the differences? Why would you pick one over the other? And quite often, I think SQL profiles became used a lot because of the script. As I say, people just grew used to using SQL profiles. But then the question that I always get asked very, very frequently, actually, is how do I evolve my SQL profiles over time? Well, maybe not exactly in those words, but the question is that my SQL profile was good 3 weeks ago, but now it's not so good. It's not really giving, I know there's a better plan, but of course, how do I tell the SQL profile to take on board that extra plan and do something with it and use it and so on? So what's actually happening is SQL profile is kind of put in a box around the SQL statement, and it's now kind of left to you to sort of find a way of changing the SQL profile or modifying it to make the plan do something different. Well, that's the key, one of the key differences here, whereas in SQL Plan Management and SQL Plan Baseline, that capability is built in. So we'll take a look at that in a minute.
Okay, just a couple of quick questions before you get on then. So first one from Rachel is, how do we find out if we have the license for SQL Plan Management? Or
so SQL Plan Management is available Enterprise Edition, and it's not an additional costed option to Enterprise Edition. Also, in Standard Edition, there's a subset of SQL Plan Management available to you. So in fact, you can use SQL Plan Management to enforce execution plans just as you can in Enterprise Edition. So in fact, you can use SQL Plan Management pretty much everywhere. Is that right saying? Well, EE and a subset in SE. So it's not restricted to, say, Exadata or cloud or anything like that. It's available everywhere. And if you're ever in any doubt, just Google, the Oracle license guide, because in the license guide, it is pretty now. In fact, we've improved the wording a little bit now. It's pretty explicit about the fact that it is available. So, because the license guide, I think, was a little hard to understand for sure in this area. But as far as I'm aware now, it's all. In fact, I looked at it this morning and it looked okay to me. But in terms of understandability, so yeah, you've got it.
Yeah.
In summary.
I'll share the link for the license guide for people in the chat in a minute as well. Okay, right. So a question from Marlon. Does the plan management maintain its baseline after a migration to a new database version from on-premises to cloud?
Yes, so SQL Plan Baselines, it was for baselines, this question, was it, Chris?
It says plan management, maintain its baseline. Yeah.
Yes, it does. So in fact, it was made to be portable, and it was also made to, if you like, that one of the major points of SQL Plan Management is to be able to use it in an upgrade or migration project where you're moving a database from one platform from another, or you're upgrading a database. And the way we do that is that we use a signature. So the signature is the thing that matches SQL statements. So even if things like, I don't know, other attributes of the system change over time, the signature is used to match the SQL Plan baseline. So it is resilient to that movement and upgrade process that you might be doing. That's one of its key, it must do that. That's one of its key things, because the whole point of SQL Plan Management is, as it was originally conceived, is to be this strategic thing that you can deploy across your entire database if you wish. And then if the database changes, it continues to manage those plans for you. So, yeah.
Yep. So I think the answer is yes, basically.
Yes.
Yeah.
Short answer is yes.
Yeah. That's good.
Thanks, Chris.
Yeah, no worries. I think we'll just take one more. I see there's some more coming in, but we'll have one more and we'll come back to others later. So again, from Rachel, I think this is a good question. And saying other experts are saying we should minimize use of hints in production. Have you encountered any issues with this, and how is how is this different? I'm guessing she's asking, are baselines different to putting hints in your code?
Yeah. So this is a large topic of mine, or sometimes a rant. Is that you do see hints put in, let's say in production code. Sometimes it's put in the client side where hints are added, and I personally, I don't like that approach very much. Obviously, this causes a storm of protest on different sides of the religion, I guess. But the big problem with hints is, number one, they don't guarantee a plan. So if you don't use a full outline and you just use, full table scan this or index that, things change over time. And unless you use a full set of outline hints, the plan's not guaranteed. So I think it gives you a false sense of security that, you know, you think you've got your plans constrained by the hints, but in reality, you almost certainly haven't. And then I think the other real major issue I have with hints is that things change again over time. So the schema changes, let's say, you might add a new index, for example, you discover a new index, but what you've done, for example, in the code, you've actually told it to scan the table rather than use an index. So all of a sudden, you're losing control, the ability to control your database. So in other words, if you've improved something at the schema level, there might be hints in the code that prevent those changes from being utilized. And that to me is just the biggest killer argument really for not doing it. So I always prefer that if you want to control, because some SQL statements do need a hint of some description or some way of controlling the plan, you know, it's not always perfect. I would look at doing that from the outside. So not putting it in the application, but looking at, a SQL profile, looking at SQL Plan Management to do that for you. So that, in other words, you control the plans outside the application. So you keep the application pure, clean. It doesn't make any assumptions about what's going to happen to the schema in future, for example, or it's not making any assumptions about how the data is going to change over time. It's very risky. You know, a new application, for example, assuming that the schema or the data distribution is going to be a certain way. Who knows what it's going to be like? So I do think using these sort of plan management objects as a mechanism to get the control that you want, but keep it outside of the application. So that's why it's different. You know, hints in the application code, I think, you know, there's always a place for everything, right? There always is, but I think in general, generally speaking, I think it's a really bad idea going down that path.
I'd agree with what you're saying there, Nigel, because it's like you say, well, let's say you decide you want to start playing with in-memory and you've got a whole bunch of hints in your code, then you won't use the in-memory column store or any other kind of physical tuning options that you might come up with, right? The hints can then prevent those, and you know, you're in that awkward place where you have to change your code.
I can't resist it. I am going to give you a little anecdote here. I'll make it quick, but I used to work a lot on Exadata proof of concepts, and we'd actually work on real workloads. So a customer would bring a workload, test it on the Exadata, and you know, hopefully it will go a lot faster. That was the idea. But we occasionally had workloads that were heavily hinted. And you know, the people responsible were lovely people and very, very clever. They knew exactly how to hint things. But the problem was, you're on a new platform now. The rules are somewhat different. The hints are not so great anymore. So what we could do is, you know, it's a little bit mean, but we used to run the workload as is, and then run it. We'd actually disable the hints with the hidden parameter as it was then to turn hints off, and then we run that through side by side. And of course, the one without the hints was the one that was winning. And you know, honestly, it always did that. And you know, it's hard to believe, but that's what we saw. You know, it was the hints for me were always a fairly corrosive thing. I've been in a lot of environments where hinting became kind of legend. You know, you'd have the person who was legend at hinting, which putting it in the code, worrying. If it's outside the code in profiles or in SQL Plan Management, better. No, it's not intrinsically bad, but it's better.
Yeah, good anecdote there. All right, I see there's some other questions, but I think if we probably come back to those a little bit once you've. Okay,
I'll push on a little bit. SQL Plan Management evolution now. So the trick here is, imagine we have a SQL Plan baseline. So now it's fixing our plan in theory. So what happens is when we hard parse a SQL statement, we have a look to see whether the plan we get matches the one that's approved in the SQL Plan baseline. If it doesn't, we'll capture it. So we'll capture that new plan. So we've seen something new. Let's record it so we can capture that in the SQL Plan baseline. You can see in the baseline view as no, accepted is no. Then there's a task, a background task that which you can run manually, or you can run in the maintenance window, what have you, that will actually compare those plans. It'll run them against one another. And so it'll physically test execute them to see which plan works best. And then if you choose to allow this, the better plan can be accepted and made available for next time it's hard passed, and it becomes accepted. Okay. So the maintenance window, you can leave this to do that. If you're using 12C and above, in fact, the maintenance window task is enabled by default. Some people didn't like this because it was new to 12C, where evolution would start to kick in, and DBAs were, in some circumstances, controlling it very tightly. So they weren't very happy about that, some of them, but you can control it. So the way I advise doing it is if you're using 12C and above and you don't want evolution to accept plans for you, just tell it not to. So this little setting here is really the magic switch, I would say. Oops, sorry. So this is the magic switch here. So yeah, the idea behind it basically is to allow plans to change in a controlled manner, and without you having to figure out which plans are better than the others. If you really want, in fact, you can just report. You can generate a report. In fact, the metadata for the reports are generated when the task runs, and you can look at the report anytime you like. So it's really nice to have that resource available to you, because what it basically says, what you've got here on the left-hand side is, okay, test my plans, but don't do anything yet. I want to have a look at the report. I want you to tell me which plans are better than the other. And now at this point, you can now choose whether you want to accept them or not. And you've not had to do any hard work to do that. It's just doing that for you. And to me, that is really handy. That is really useful. I like it because if you don't want it fully automated, it doesn't have to be. It's under your control, but it's not hard work. You know, it tells you right in front of you that this plan is better than that plan. And then you've got a choice whether you want to accept that or not. Okay. So I'll do the demo, shall I, Chris? And then, yeah, we'll see if there are any more questions.
Yeah, go on, do the demo, and then I'm sure we'll have, there's a few I can see, but let's
let me see the time. Yeah, okay. Demo. Demo. Okay. Right, so I've got a query. This one is going to have a SQL profile in a minute. It just joins a couple of tables. It takes about 5 and 6 seconds. Okay. This is the plan. Doesn't really matter what the plan is, actually. I'm going to run the same query again, in fact, but this one we're treating differently. It's got different text in it. It's the same query, but I'm going to create a SQL Plan baseline on this one. Takes the same amount of time, 5-6 seconds, generally speaking, something like that. Okay, so that's my plan. Now, I want to control that, and I've got a few options to do that. Let me just move the screen up a tad like this. Okay, so what I'm going to do now is load a SQL Plan baseline, which looks like this. So what I'm doing is I'm basically saying, create me a SQL Plan baseline for this SQL statement for this plan. I like this plan. I want to keep it. Okay, so now I can look at that. If I look in the SQL Plan baselines, I can see it. So if I look in SQL Plan baselines, I've got various technical data plus the query text, and it's accepted. So what I'm saying now is, I like this plan, use it, please. The other thing that's open to me is to create a SQL profile. So now I'm going to say it's SQL profile. It looks more complicated, but really it's not especially. So it's pretty quick. In fact, what this SQL profile is doing is it's using the support script that I talked about earlier, and it's putting in the outline here. So I'm kind of, it's a bit of a trick, slightly a backdoor, but it's now creating my profile. I can now look at my profile. So now I have a profile call with this very long name. This is actually the default name the script gives it. So descriptive, the SQL text, and it's enabled. Okay. So now if I run my scripts again, this one for the SQL profile, I like this plan, therefore it's going to take 5 or 6 seconds. But when I look at the plan this time, it tells me that the SQL profile is being used for this statement, just as I wanted. If I run the other query now, same query basically with different text in it, Again, 5 or 6 seconds, but this one's telling me a SQL Plan baseline has been created for that plan. Okay. Now, over time, things change, and the way I'm going to change it in this case is create an index. Simple as that, really.
Thinky.
It's quite a big table, this.
Yeah.
They have to be big, otherwise the queries run too quickly. You know, you have to write millions of blinking rows, really. So create the index. Now we run the queries again. So this is a useful index, of course. I know that this index is going to really help me out here, but it's still taking a little bit longer there, 5, 6 seconds. Why is that? Well, it's because I'm keeping the existing plan just as I intended. That's what I wanted. You know, the SQL profile is fixing it. If I run it with the SQL Plan baseline, 5 or 6 seconds later, it's going to come back. So effectively, the index hasn't apparently done anything. I'm using the SQL profile. So I've created the index. So creating the index is an analog for change, right? Things change over time. It might be an index, you might drop an index, you might change the data distribution, all sorts of different things can change, which means the plan probably has to change. But if we look in the baselines, we've got 2 entries now. One of them says yes, and one of them says no. This is in fact the new plan. This is in fact the plan that uses the index, but it's not being used yet. As we saw when we ran the query, it didn't change. When the index was created, nothing happened, but we did capture this information here. So in fact, if I look at the baseline plan, you can in fact see that if you use display SQL Plan baseline for the handle, you can actually see that I have 2 plans now. So I have, this one is the original accepted plan. This is the new plan, and now it sees this new index. So this plan has become available, but it's not being used. So that's if you like, the key trick. Now we use evolution. So I'm running this manually. If you want, you can just use the default task that runs in the maintenance window. So the evolve process finishes and then it generates the report. So if we kind of look up the report, it basically says the base plan, which is my original plan, took 5 seconds, as we know, 5 or 6 seconds. But if I could use the plan that I get with the index, it's super quick. And in fact, I've allowed it by saying accept plans to true. I've allowed the evolution process to just accept my plan. So if I look in the baseline now, this new plan has been accepted. So now all the plans are accepted. So now when I run T0, my test queries, this is one of the SQL profile. Okay, SQL profile has an outline in it. It's not going to use the index. It's not allowed to. So at this point, you're in a position where the SQL profile is kind of, I'd argue it's over constraining the plan at this point. You know, there's an improvement, but you're not taking advantage of what's happened in the database. We now run the baseline one, but now it's sub-second. We're looking at 0.03 seconds. And why is that? It's because now we've allowed it to use the new plan. It is being constrained by the SQL Plan baseline, but the new plan, the one that we know is better, that we've seen through the evolve process. And so now it's using our new index. So this, if you like, is an automated mechanism to allow the plan to change and transition over time. So this is what's available to you if you use a SQL Plan baseline. I think that's the big headline difference, really. There are a bunch of differences as we discussed, but that's the kind of the big headline difference.
Yeah, so basically with SQL profiles, you need to manage it yourself, right? You need to know something's changed.
Yes. And so if you use SQL Plan baseline, you can use the framework, the management framework, to do it for you. That's really what it's about. Okay.
Yeah.
So
okay.
Questions?
Yeah, I was going to say there's a whole bunch of other questions. So should we go through some of these now?
Yeah, I think so. Yes.
From Anis, is RAT real application testing works with the same approach with SQL Plan Management? I don't know a huge amount about RAT, to be honest, but
so again, because SQL Plan Management is essentially an adjunct. Okay, it's something you can use outside whatever's happening. You can always use SQL Plan Management with all these other tools. So you can use it with any general purpose application, with things like RAT if you want as well. Absolutely. So if you want, you can run a RAT workload, capture that as a SQL Plan baselines, and then from then on, it will always use those plans that you used in the RAT workload. And of course, generally speaking, with RAT, you're looking at change, you're testing change, aren't you? So you run RAT on one system, capture all the plans, move it to another system or upgrade it or whatever you want, run the RAT workload again, and then it should keep the plans it had before. Also, you can turn SQL Plan Management off. And so you could also run it with the plans that it would have if they weren't constrained, and you can compare one against the other. So yeah, it's pretty cool.
It's pretty unique. Another kind of combination of technologies question here from Rangapavan. SQL Plan Management versus SQL Quarantine. These two independent of each other.
They are quite different. Yes. So SQL Quarantine essentially makes use of DBRM, the Database Resource Manager. It will stop individual plans from executing again if they are seen to exceed a specific period of time. They can be used together again, so you can create SQL Plan baselines for your SQL statements, and then in theory, of course, you're never going to need SQL Quarantine. If you capture everything, then in theory, you might never need SQL Quarantine because, but nevertheless, you can use them both together.
Yeah, cool. All right, then a question from Bob. So even with stable baselines, profiles, and so on and so forth, let's say one day there's a whole bunch of changes. So we delete a whole bunch of rows and the table increases rows by a factor of 1,000 or something. And so using the existing profile, the query goes from a minute to hours or something like that. You've got hours to wait until the maintenance window. So, what can we do if, things have changed rapidly and we don't want to wait, or we can't wait till the normal maintenance window?
Yeah, makes sense. So in fact, you can run the task anytime you like, just as I did in the demo. In fact, you can just run the task immediately. So if you want to preempt that, there's nothing to stop you running that anytime you want. So obviously there needs to be some resource available to test it. The machine can't be fully utilized when you do this, but as long as there's space in resource when you run it, it's going to run it. So you can do it anytime you want. There's no constraint on that. So you can test it immediately if you want to. And in fact, that's what we do in Autonomous Database. So there's a thing called high frequency SPM. So in fact, we run it essentially almost continuously. So in fact, we run SQL Plan Management, the task, the Evolve Advisor task all the time, pretty much. It just kicks off. So it's always looking for these regressions to happen, testing them with Evolve, and then applying the new plans. So if you want to sort of copy that, you can. You could run the tasks if you want much more frequently. It's up to you.
Yeah. Cool. So you could do like in Autonomous and run it continuing yourself if you really wanted.
If you want to, yeah, that's right. In fact, it's always, I almost think it's worth looking. Well, it is worth looking at Autonomous DB for the sort of features that we've got in there, because you can sort of see Oracle's strategy and direction in there. ADB at the moment is leading with a lot of these sort of auto features, but if you look at the way they work, you'll see that in fact you'll learn things about how you might want to do things yourself, and that's specifically around SQL Plan Management, because that's quite core now to the way Autonomous works. And also it's true of what's called the automatic SQL tuning set. So if you go to the Optimizer blog, there'll be a link at the end, you'll see information on the automatic SQL tuning set as well, which is something you can definitely learn from, as a technique that you can apply in a more sort of manual fashion yourself, and take advantage of the sort of tricks that the database has built into it. Okay,
cool. That's an interesting little tip there, Nigel. All right. Some more questions. So Subhashish, if we have a profile for SQL and there's a better plan for the SQL, it will not be used automatically without manual intervention. Or so we've got a profile, we need to do something to change the plan.
Yeah, so in fact, I could probably run through this really quickly to show you. If you need to change the plan, you can do, let me just quickly show that you can in fact use these things together. So if you have a SQL profile, bear in mind that these technologies can very much be safely used together. So I think sometimes people are afraid that they can't be. But let's say you have a SQL profile that you've got that is enforcing some plan, and you suspect or know there's a better plan available and you want to kind of move things on, you can kind of do that. There's a little trick you can do that. If you have a SQL profile, your SQL statements using the SQL profile, you can in fact just create a SQL Plan baseline on it as well. There's nothing to stop you doing that. So load it from the cursor cache. I've created myself a SQL Plan baseline. So in effect, both these things are working to constrain the plan at this point. So you'll see it will say I'm using a profile and a plan baseline. Okay, there's nothing wrong with that at all. It's just fine. And in fact, if you want, you can disable the SQL profile. At this point, the plan stays the same. But if there is a better plan or a different plan, that gets captured now by SQL Plan baselines in the SQL Plan by SQL Plan Management. So now you're in a position, in fact, to run an evolve task on that and say, actually, which plan is the better one? The one that I currently have that was created by the SQL profile, or the new one that the optimizer thinks I should use now? So if you like, I think of it, you're kind of handing the baton from SQL profile, the SQL Plan baseline, and then using the evolve mechanism to say, tell me, do I need a different plan now? And if you really want, and if it says no, if you really want, you can drop the SQL Plan baseline and go back to the profile. You've got all those things you can do. You can sort of pass the ball backwards and forwards between the two. So if you think creatively a little bit, it's really super strong what you can do. You got a lot of flexibility. Because I own SQL Plan Management, I think what you might want to do is use the profile as a technique to find better plans and then use SQL Plan baselines to manage them in the long term. That to me seems like a good, using both technologies in the way that they were built and to gain strength from both of them. So that's what I like. That's what I would do. Okay. But yeah, people have different preferences.
Yep.
Okay, I'll get to the comparisons in a bit. Yes.
Yeah, all right then. So another question from Rachel. When is it reevaluating the plans? Could this cause performance issues during work hours or busy times, I guess?
So you're right to think about that, of course, that you are literally test executing one plan against another plan. So the way that is done, and in fact, totally by default, so really don't necessarily have to think about it. It just occurs in the maintenance windows. So the evolve process where it tests one against the other happens inside the maintenance window by default. If you don't want to do those sorts of things, of course, you can disable them entirely and then run the evolve task manually whenever you want. I'm not sure exactly what that will gain you, but as long as your maintenance windows are set sensibly so that you're using them as a window of opportunity, then it will fit within, it will occur in those windows. So that's when it happens. Okay. So the idea is that, we are attempting, of course, to keep that test away from, your workload.
Yeah. Cool. All right then. So this is a good question. So you've got queries where you've got like column in, and then it could be bind 1, bind 2, and then you might have bind 1, bind 2, bind 3.
Yes.
And the number of bind variables could change each time, basically.
Yes. Mm-hmm.
How can we address? Have you got what would you suggest for using these technologies, or is there a way we can use these to address that?
That is always a difficult problem. But what I would say is you don't need to be afraid of collecting a large number of distinct SQL statements. SQL Plan Management is designed to work with a large number of SQL statements. Now, that means that if you have an in list that varies between 1 and 1,000, that means in theory you're going to capture, as long as they're bind driven, you're going to be capturing 1,000 SQL Plan baselines. That's not necessarily a bad thing. Well, it's not a problem. That's nothing. We can capture millions of the things if we really want to. It's designed to do that. Actually, I should make a quick mention here that in the early days of SQL Plan Management, I think it got a bit of a reputation for capturing, because the plans take space in sysorks. So I think it gained a reputation of being difficult to deal with because it would take space in sysorks, and we actually used to struggle to purge them down, the ones that are not used. That's all been sorted out now. So there seems to be very little reason not to capture plenty of SQL statements. It's not an issue anymore. So for those in-list SQL statements, I don't think it hurts to capture them all. And of course, the cost estimates will probably vary as the in-list grows. You know, the number of rows, the cardinality is going to shift. So in reality, each one, well, each set, you know, like every 5 in the in-list or something, might even have a different plan, or there's some kind of crossover. That's fine. That's manageable with SQL Plan baselines. Just, I think you should capture them all. You know, just capture them. You know.
Yeah, okay. That's good advice. I think there's kind of a related question here, is how many plans does SPM, or how many accepted plans can you have for
right, there is no absolute limit. We don't enforce a limit. So there are systems out there with millions. So you can, yeah, you can have a lot. And I think, you know, in the back of my mind, we kind of assume, if you like, as a sort of ballpark design decision, we kind of assume you've got up to about 1 million, but for sure you can have more. But you know, if you think if you're under 1 million, you're completely fine. You know, it's completely designed to handle that, no problem. And there's no limit above 1 million. There's no absolute limit. It's just like what I think a developer has in their head, that you probably have no more than about 1 million, but we can handle more than that. You know, I am aware that there's at least one database out there, and I was told they have about 600 gigabytes in plans stored in sysorks. It's just enormous.
Wow. Okay.
And it works. You know, it does work. You know.
Yeah.
So that's the thing. So I think, in fact, I've got a blog post on this that's about to come out. Really, that if you look at autonomous, we are looking at capturing more about execution plans, about the performance of SQL statements. So all of our frameworks are designed to handle really large numbers of SQL statements and plans. That has to work. And in fact, one of the reasons and for motivating this again is things like autonomous, where, you know, we can capture just gazillions of plans, and so yeah, it's built to cope with that. So I wouldn't assume an upper limit, but I would say wouldn't even consider it particularly surprising if you've got 1 million.
Yeah. Well, okay, that's reassuring. Good to know. Another question. So we've got a query, and let's say we've added a column to the table, so we need to add a column to the query as well. So we need to recreate the profile and so on. Is there an easy workaround for that, or is there?
Not really. So with the profile, you just got to deal with it. I think with SQL Plan Management, what some customers do is they just auto capture everything. Now, I'm not 100% sure about this, whether I really want to auto capture all the time, but the way SQL Plan Management can operate is you basically flip a database parameter and say, if you see new SQL, then grab it and capture it. And that means if it's executed more than once as well. So if it sees a SQL statement, once it's executed twice, it becomes a candidate for a SQL Plan baseline, so it'll create it for you. So the way that you could choose to deal with this is if, for example, you know there's a design change or a new release of code or something like that, you could set auto capture on to capture all that new SQL as it happens. And then, you know, after a period of time when you're sort of confident that those queries are run, then you can turn auto capture off. That's what I would do. You know, just build it into the release profile, capture them. In fact, you can capture them and not use them if you want. So there's another nice trick. You can say, I'll just capture them. I just want to know what my plans are, capture them. If there's a problem down the line, I've got this, you know, this repository of plans that I can look at and decide, actually, this is a better plan than that one. Let me impose that plan. It's a good sort of tool to get you out of trouble quickly as well. You know, if you have a regression, then you might have the plan already, and just enable it.
I guess that gives you a kind of a historical record. If things change, you go, oh, this is what it was back on day one as well, doesn't it? So
Exactly, yeah.
you can easily compare.
Yeah, that's right. So the way that Autonomous does it, in fact, we use the SQL tuning set as a mechanism to capture all our plans. So in fact, we have an automatic SQL tuning set. We actually bundle all our plans in a tuning set, and then we use that to feed SQL Plan Management when we want it to feed it. So that's what we actually do. So you could choose to copy that, or you could just copy the plans directly in the SQL Plan baseline. It's really super flexible. So my advice to SQL Plan Management is that I think a lot of people are put off by it. They're thinking, I don't want to capture all my SQL. That's fair enough. It's a big change. So use it more tactically. Get used to using it, and once you get familiar with it, it becomes second nature, and it's actually really nice to use. It's good.
That's cool. Kind of on that topic of using it tactically, someone's asking, can we just use it on an existing SQL ID, for example? So just limit it to one statement or one set of statements.
Yes, absolutely. So you can basically say, load it from a SQL cache. So once the statement is in the cursor cache, you can just grab it out of there and create the baseline for it. And if you want to just do that with 3 SQL statements, absolutely. You can target it that finely. So this is the thing I think that's sometimes not well understood, and it's the way we kind of originally spoke about SQL Plan Management, because it was designed to be this thing that you could kind of deploy across everything. And I think that created a certain degree of fear. Wow, that's quite a big change. I don't really want to jump in the pool, pool that deep.
Yeah.
And I can understand that. So my answer to that is really use it in this way we're discussing. Be tactical with it. Use it here. Check, evaluate it, prove that it gives you benefit, and then you'll see you can then gain confidence in using it and more adept at using it and see its value, and then you may choose then to expand its usage. That's fine, but I'm like the treat things cautiously approach. It's good, why not? And it will work in that manner. So there's no need to fear about it kind of taking over the world immediately. Just start small and then see its value, and then if it earns its value, then you can choose to use it more if you want.
No, that's good advice. Good advice. So based on what you said, I think I can guess the answer to this, but it's saying, does SPM support in-memory operations?
Yeah, so in fact, that's a good question, because in fact, I think I've blogged about it. It's like in prehistoric times, but yes, yeah, it does. So any plan is up for grabs, so it's fine. And in fact, if you look at, I think there's a white paper on this that Andy Rivenis produces that says, if you want to test like with like, you can, in fact, what he recommends is you can grab your workload in SQL Plan and baseline it all. So if for example, you're doing a benchmark, just store all the plans that you have before you turn in memory on, then turn in memory on, and then run it again, controlled by SQL Plan baselines. That actually is a sound technique, because the baseline will still work, even though the scan previously would have been a scan of a table, and now is a scan in memory. You will use the same baseline. It treats those plans, if you like, as the same, right? So it'll say it's an in-memory scan or a table scan. That's basically the same. Therefore, I'll use the Plan baseline. So yes, it does work within memory. And if you want to, as I say, you can say, I don't want to use, when you put in memory on, you want it to, if you just specifically want to see the value of the scan, but keep the plans the same, SQL Plan Management gives you that capability as well. So yeah, again, flexible, really.
Cool. All right, we're getting towards the hour, so I think we'll just 2 last ones before you do your wrap up.
Yeah, okay, I'll reverse the wrap up.
Okay. All right, so quick question from Marlon, kind of interesting one. He's saying, SQL management performs properly as long as the system is not oversubscribed by core or memory, correct? So basically, hitting the resources limits.
Yeah, so if you want to use Evolve, you need spare machine capacity to do that. You can manually evolve. So when I say manually evolve, you can say, look, just evolve this. I know it's a better plan. But if you want to actually physically test execute one plan against the other, you need resource to do that, of course. Now, if the machine is fully utilized, the evolve will still run, of course. It can still run. We just gassed a queue for the CPU. But yeah, which is why, generally speaking, you would run evolve in the maintenance window, because again, it's another, it's taking resource. So of course, you don't have to use evolve. So if you want to just use SQL Plan Management as a mechanism to control plans, you do that. You don't need to sort of have this additional resource available. But if you want to use evolve, you do need really to pick a time to run it when there is spare resource. Yeah. So in summary, if the machine is fully utilized 24/7, you might not have room to run evolve. But if you want to use SQL Plan baselines, you still can.
Yeah, I think my thought is if you're on a system where you're kind of at that limit, then you probably got bigger things to worry about anyway.
Yeah,
right?
That's true. Yeah, and of course, when you're on a 100% utilized machine, the response times just blow out the water. You queue forever. So,
yeah, exactly. All right, so I think we'll have one last simple one, then you can do a quick recap.
Okay.
Someone's asking, is there a QA forum or some way people can reach out to you, to ask you these questions?
Yes. So the easiest thing to do, in fact, there's two ways, or three ways. You can email me. My name's Nigel Bayliss, oracle.com, BAYLISS. So I'm happy to take emails, absolutely. I have VLDBB. There's a summary at the end of this. The other thing you can do is post questions to the blog. In fact, let me just skip to the. Oh, I didn't put it in here, did I? Oh, yeah. It's on the first screen, unfortunately. I'll put the first screen up again in a minute. But yeah, so you can email me. If you post comments on the Optimizer blog, they don't get published instantly. I read through them. So if you just simply want to ask a question, and you don't want it published, just say that, don't expose this, but can you tell me this? Then I'll look at it and I'll get in touch with you. So you could use that as well if you like. So you can post stuff to the Optimizer blog without it being posted instantly. I have to see them first and then tick the box. So,
cool, that's good to know. Nice little trick there.
Yeah. So yeah.
Alrighty then.
Great.
Yeah, I think if you kind of recap,
I'll rattle down this.
Yeah.
So it's designed to offer an end-to-end management of plans. That's what SQL Plan Management does. SQL Profiles were designed as a tactical feature to be used with SQL Tuning Advisor. That was really what they were designed for, of course. SQL Profiles have force matching, which is great. SQL Plan Baselines don't have force matching. You'd have to use the cursor sharing switched on if you wanted to do that. So that's currently one of the reasons why, if you are using them just to control plans, is why sometimes SQL Profiles are used if you've got a lot of dynamic SQL. So yeah, that is a big difference. SPM allows a statement to have more than one plan. So I didn't really talk about this much, but you can have more than one approved plan. And so if a SQL statement needs to use multiple execution plans based on bind value type, SQL Plan Management allows you to do that. So it does offer the scope for that. So bear in mind, I think that SQL Profiles can under constrain plans if you use them like with just random hints, as we discussed before. Hints don't fully, just basic hints don't fully constrain a plan. And then I think they over constrain, which is the example with the index. If you fix a plan, it's kind of set in stone and there's no easy way out other than kind of doing it manually. So SQL Profiles, importantly, don't care about what plan you use. They just don't care. If the plan that you get doesn't match the plan you thought you wanted, it doesn't know. It doesn't care. And it just marks the SQL profile as being used in $SQL. You have no idea whether it's actually using the plan you thought you wanted. Whereas SQL Plan Baselines do. That column only gets filled in $SQL if the SQL Plan Baseline is used and the plan is used. So you can tell immediately that a SQL Plan Baseline is actually giving you the plan you wanted, whereas it's not quite so easy with a SQL profile. Okay, and if I just whip back to the beginning,
yeah.
Those are the links that I was talking about earlier, the blogs,
yeah.
the VLDBB, and the Optimizer blog. So yeah, just there if you want. And that's my name. So emails easy to guess. Nigel Bayliss. Nigel.bayliss. Okay.
I've stuck it in the chat for people, so if anyone wants to grab
good.
that, they can pick that up. All right, then. I think there might be a couple of other questions, but we're kind of past the hour now. So I think we've taken enough of your time, Nigel. That was a really good overview.
Yeah, great questions, actually. Thanks ever so much. They're really good. It's nice to get a lot of questions. Yeah.
Yeah, cool. All right, anything else you want to say before we wrap up?
No, that's me, I think.
Okay, perfect. Thanks. Yep. All right then. Well, thanks all for joining us. And we will have one final office hours of the year, mid-December. I think it'll be the 15th of December. So I hope to see you all. In the meantime, stay safe, stay healthy, and we'll hope to see you next time. Right.
Bye all.
Goodbye.